Hello there. So this is the next video, and I hate it when it does that. There we go. Okay. So remember, all of these new things, these new formulas on the identity sheet, if you're given the angle, then it's going to turn into what you see here, one of the original just sine of some special angle on the unit circle. Or if you're given the number and not the angle, then it's going to turn into what you see here, and that's what we're going to look at on this video. We'll see how far it goes. So this is the next example. I'm still using the same PDF. You can see this is page 4 in the PDF file. So we've got cosine A, -4/5, tangent B is 2. So you know that those are not the numbers associated with the unit circle. Now, on the off chance you get one of these and it says cosine A equals 1/2, then you really shouldn't do the right triangle, but you don't get those very often. And you see the inequality on the right, and that tells us where the quadrant is for that particular angle. So you have to pay attention to that, just like this original homework in the lab manual way back when, and the new stuff right there. So down here, you see this is very similar to the examples that I'm working for you right now. And it's the same identities on that formula sheet. Oh, what happened? Didn't take my number there. So sum and difference, and I do some other ones in the other videos. So we're focusing just on the sum difference here. And you can see the 3 I'm doing: sine A minus B, cosine A plus B, tangent A minus B. So when you know the formula you're using, these formulas all require sine A, cosine A, or tangent A, tangent B, like that. So I go straight to the right triangle. Now you can use the Pythagorean identities for this. I just think that's overkill, but you can use them if you want to. I think SOHCAHTOA and Pythagorean theorem is a lot easier to use. Anyways, so this is cosine adjacent over hypotenuse. And so I'm solving for y. So Pythagorean theorem, we see y is 3. And then I just find those 3 trig functions that I need. You see right there, that's the SOHCAHTOA part. Do the same thing for angle B. Now, just as a huge tip, these are not the same triangle. So do not make them the same triangle and make mistakes like that. They're always going to be separate, independent triangles. So this one is tangent, so 2/1. The negatives are because this is in quadrant 3, and you know that in quadrant 3, the x and y values, or opposite and adjacent, are going to be negative. So right up there, that inequality told us quadrant 3. Now you can label the triangle with the negatives like I've done, or pay attention. Ooh, pardon me, I'm hiccuping or coughing, I can't tell which. Anyways, so put the negatives on the triangle, put the negatives for the trig function, but you have to pay attention to those quadrants because that will affect your final answer and the points that you get as well. Okay, so you can see I did the SOHCAHTOA down here, and now we just go straight through that identity. Now, the previous video, I didn't write the actual formula down. You can always do that, but I personally find it helpful when I'm dealing with the A and B to actually write down that formula, and then you can see I'm just writing the number directly below. So sine of A is 3/5. Directly below it, I write 3/5. Cosine of B was -1/√5, and I just write it directly below that. That's just me. I like the visual connection there. A little bit of arithmetic. You can see what I did there, and then simplify the numerator. Sometimes you simplify afterwards. Again, I'm not rationalizing. Don't worry about it. That's just extra work. Don't waste your time. Okay, so then we're going to do cosine of A plus B. We already did most of the work up here with the right triangles, Pythagorean theorem, and SOHCAHTOA. All we're really doing now is finding the identity on the formula sheet and putting those numbers where they're supposed to go. So always, be as familiar as you can with that formula sheet, where they are. And, we're told the formulas that we're going to use up here. So that's one of the differences in if you're given the angle measure, you are making the decision on the formula, but when we're given the number value, we're actually told what to do, find this particular formula like that. And then again, for cosine, you can see I wrote the basic generic formula, and then I'm just writing that number directly below. At no point are you actually figuring out what A or B is. So please don't lose points for writing cosine parenthesis -4/5 in place of the A. That is extremely wrong. No matter what else you do, that tells me you didn't learn something. And then do the arithmetic, combine, simplify, don't rationalize. Now, if you just automatically rationalize, I don't really care. It's just an extra thing that you don't have to do. And the last one is the tangent. So there's the formula. And so each of these three formulas, I'm going back to these original triangles that I started with and just using these SOHCAHTOA values that I calculated based on those triangles. So we're dealing with tangent now. And I just plug those numbers in. This one has got kind of multi-level fraction going on. And what I do is just take the common denominator of all the terms, multiply everything, so I'm not having to add or subtract fractions. Now, this particular test, you can use the calculator, so, or, just write it out like this. So we got 4 in the -3 and 4 in the 2. You can see that. And then the denominator, 4 times the 1 up front. And then 4 cancels that denominator. You can see exactly what I'm doing. And then simplify, boom, you're done. So I'm going to look for another example with right triangle and see. This is a half angle. I'll come back to it in another video. This is another pi/8. Haven't seen that before. I'll come back to that in another video. Another angle measure. Okay, so this one, we're using some different identities, but the idea is the same. So this is a half angle and a double angle. And you'll notice this one is cotangent. And there's not a cotangent. So what do? Well, you take tangent and you just literally flip it over. You can calculate tangent and get the answer, the number answer, and flip it over. Or you can take these formulas and flip them over. Now, the formulas that are fractions, I would literally flip over the fraction and use it. But the formulas that are not. So if we were trying to find cosecant of A plus B or cosecant of 2A, I would probably find sine first and then take the number and flip it over. Because I've talked about doing the 1 divided by, and that makes it a little more complicated, and I try to avoid that. So it just depends on which formula you're given. If it is this fraction form for those, just take the formula and flip it upside down. Or don't. I mean, it all depends. So let's see. What are we doing? Okay, I'm right here. I'm trying to figure out what I'm doing. Okay, so cotangent of A, 5/12. A is in quadrant 1. Cosine B, -3/5. B is in quadrant 2. Remember, these are just the same as those original, that assignment you had way back. There's similar ones on WebAssign. I'm just looking at the lab manual here. We're told the quadrant. Sometimes we're given an inequality in different ways. You can see some of these say sine is less than 0. That tells you a specific quadrant when you're doing that. Sometimes on these, we like that other inequality, like you see here. So you'll be presented this information in different ways. So just be aware, always check that quadrant. You're going to be told that information somehow. All right, so let's go back. So you can see I just go right to the right triangle, Pythagorean theorem, SOHCAHTOA. So cotangent is tangent flipped over. So the opposite is 12 and the adjacent is 5. And even though I don't need the 3, I kind of just by default write them down. You can always look ahead to do the cotangent half angle. Get to the right. The cotangent half angle just uses sine and cosine. It doesn't require tangent at all. So it just depends on what you do. I just write everything down. And there's the B. So I kind of ran out of space at the bottom of the page here, so it's kind of cramped in there. So for cotangent A, we only need the triangle for A. This is just one angle. It doesn't involve B at all. So you can see my cotangent, And I wrote the formula down to help me out. And I used the one on the right, the half angle. There's two different variations, and you can see I wrote it flipped over to help me out. So 1 plus cosine on top over sine. That's the tangent flipped over right there. And then I just plug those numbers in where they go. Same technique I did before, multiply by the denominator, simplify, 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 and you're done. This particular cosine B, we don't really need the triangle at all, which is why I didn't write sine B, cosine B. Look at the formula for cosine of the double angle. It's got 3 variations, one of which just uses cosine. So I was given cosine to begin with, so I didn't need to do all that other stuff. So if you needed to do all that other, then you would, do that other stuff. But I just dropped that cosine of B, -3 over 5, square it, 9 over 25, multiply, subtract 1, you're done. Like that. That's the end of this video. So I'll do the rest of the examples as soon as I remember which ones I haven't done.